real pleasure to be here. So, yes, I'm from Wake Forest, and I borrowed a green laser pointer from the physics department. So this is my little treat tonight. I can advance my slides while being out here. If you were sitting really close to the screen, you may want to just back up a little bit. And in the back, hopefully you'll be able to see some of these pictures. I hope to give you a little treat tonight of learning about some of the things that go on inside of each and every one of your cells. So inside of your body right now, there are 100 trillion cells keeping you alive, allowing you to think thoughts. And a lot of what has happened in the intelligent design community with Michael Behe and Bill Dembski and some of the others has come because of unpacking what goes on inside of the cell. In fact, Michael Behe's book, Darwin's Black Box, if you've ever wondered, what is this black box? It's the cell. It's looking inside of the cell. Now, that's not to say that intelligent design is only about stuff inside the cell, but it's a good place for us to start. And since I'm a biophysicist in the physics department, I hold joint appointments also in some other more biologically related departments. I will, feel most at home there, and hopefully can teach you a little bit about what goes on inside the cell. So if nothing else, you'll gain some of that. In fact, this first slide has a picture, and I don't want to block what I'm showing here, so maybe I'll stand to the side. But I also don't want to get tangled up in all these dangerous cords. So this is called the DNA copying machine inside your cells. Several parts not shown. So tonight, you'll be looking at some really weird looking objects, including an animated version of this machine right here, that will hopefully describe to you a little bit better what goes on inside of your cells. The outline of my talk is, like I said, I've been harping on this for a while. It's molecular machines I study. This will be like taking molecular biology 101 tonight. So I hope you guys aren't going to fall asleep on me. If I start to see heads nod, I'll take that as a sign that I need to skip to the next part of my talk, which is the good and bad ways to frame debate. I know there are a lot of people out there, budding philosophers, and a lot of people who are thinkers. So you guys know the importance of properly framing any debate so you can have a reasonable conversation. You don't shout at each other, you don't talk past each other. And there are good ways to frame the intelligent design discussion or debate, and there are bad ways to do that. And I'll be talking a little bit about some of those. I'll be using the parable of the tax collector and Pharisee just as a launching off point to talk about this really hot topic, Earth age. In the evangelical world, that is a real big up-in-the-air issue. It can be interesting to discuss, but it also can generate a lot of bad feelings, and a lot of people who, like the Pharisee, look down on other people. Whether you're one side or the other, you might look down on the people who don't hold your views. So I'll just share my views about that, and then come to the final point, the main point was, we need each other's support. Whatever you feel about intelligent design, or about the age of the earth, or about any number of science and faith issues within evangelical Christianity or the broader conversation, we just need each other's support. We don't need to be fighting each other, especially evangelicals fighting evangelicals in some of these arenas, because there's enough other fights going on. We don't need that. So that's sort of the main point here. And I look forward to getting your questions at the end. I'm going to only take up 45 minutes or less because I really want to leave as much time as possible for your questions. So anyways, again, my name is Jed Macosko. I'm from Wake Forest University. And just a little bit about myself. I grew up in Minnesota, and I went off to college at MIT in Boston. And there I got a degree in chemistry. And went away as a missionary with Campus Crusade for a year to Uzbekistan. And it was while I was in Uzbekistan that I read some books that really convinced me that I needed to sort of shift out of straight physical chemistry and into biophysical chemistry, where I could learn more about these wonderful machines. And then I went from there to Berkeley, California, that bastion of conservative thought. And it was while I was there that I met and befriended Philip Johnson. He befriended me. Took me under his wing, let me live in his house for a year, and many of you know that name. He wrote Darwin on Trial and a number of other books. So being mentored by Philip Johnson has been a real wonderful thing. And through Philip Johnson, of course, I met Bill Dembski more than 15 years ago. and we become friends. So he called me on my way down here to tell me to watch out for you guys. But just a little bit about what he had shared, so I can develop the continuity that you would have gotten if you had had the same speaker all 3 times. That is Ken Turner here. If you're here, raise your hand. Okay, there you are, Ken. Ken and I also had some phone conversations, and I'm really excited that he'll be able to speak to you tomorrow morning. Is that still on? Good. So you'll have some continuity too, because we've had an interchange or two, and look forward to hearing how that goes. So off we go into molecular machines. This is the famous flagellum. So you're zooming in on a bacterium, and now what you're doing is you're looking at the side of the skin of the bacterium, and you're watching in real time what's happening with the help of computer animation, how a flagellum is built. It's built ring by ring, brick by brick in a circle. Okay, and that's the first part that's built. And then there's this little disc in the middle, a hollow disc. And up through the middle is extruded, that means squirted, a bunch of other proteins that form new rings on the outer skin of the bacterium. Okay, and then each one of these is coming out through this hollow tube. Okay, so, and there's this star-shaped thing, you guys in the back probably can't see this, but it's a star-shaped thing that guides exactly where the bricks go. These are molecular bricks. And now you can see a new star-shaped thing forming. This is the bent part of the flagellum that operates as a universal joint. You can ask me questions about this thing. But anyway, we're just flying through this, and this is a new star-shaped thing. And if you watch really closely, if you're in the front couple tables, you can see that the star-shaped thing has a bunch of legs on it that each swivel around, allowing the bricks to come out only at one point. And it's basically a brick mason, a bricklayer, for this wonderful flagellar tail. And it's the tail of the flagellum that operates as the propeller, the outboard motor for a bacterial cell that propels it through any liquid or sludge that it happens to be in. So here's the universal joint, and here's the propeller. It doesn't look like a propeller yet, but as it's formed, it has a natural spiral to it. And then it operates along with maybe 6 other flagellar tails as a corkscrew. This thing will bullet the bacteria through the liquid to anywhere it needs to go. If it needs to change directions, it actually has a mechanism for doing that that's absolutely brilliant and was my thesis work at Berkeley. So I just love the flagellum, and if you've ever seen, I've got a few visual aids here in my bag I don't want to forget to show. This is a video called Unlocking the Mystery of Life. Has anybody seen that? Okay, a couple hands. Do you recognize somebody from that video? I'm in that video. I'm a lot younger, okay? Made when I was still at Berkeley, and so I didn't have gray hair, wasn't married, didn't have 5 kids, you know, I'm much older and hopefully wiser, but definitely grayer and more wrinkly. So you'll see me, if you pick up this video again, if you still have it, describing my love for the flagellum motor. So, and that's the famous flagellum motor that has appeared in all kinds of intelligent design discussions. Okay, so we're going to go on beyond flagellum today, as Dr. Seuss would say, because this is where a lot of people hear about intelligent design, but we're going to go way past that. And I think you'll enjoy the ride. So here we are, again, on the outside of a cell. This time, it's a larger cell, a eukaryotic cell, maybe a human cell or an animal cell. And if you compare the size of this cell to the one you saw last, it's a real big different size. You'll see. On the surface of the cell, you see all these little bumps. Those are called phospholipids, or just lipids for short. So if you are on lipitor medicine, you're trying to lower your lipid concentration. This blue thing is a steroid molecule, or a hormone, more generally, and it can slither through this phospholipid bilayer. Well, lipids are very fatty. That's why when you eat a lot of fatty food, you get more lipids. But a hormone can slither right through the membrane. Okay? Now this is maybe a better picture of the membrane. Oops, it skipped ahead. But you can see there's the membrane right there. Okay, and inside of the membrane, decorating it, are all these proteins that kind of get stuck in the lipid membrane. And they're the ones that allow the cell to communicate with the outside world. Have you ever walked by maybe a housing development or some parts of of Mexico or other parts of the world, even definitely here in the United States. What do you see on the outside of a big apartment building? Very obvious on each of the balconies pointing off into space. Satellite dishes. Okay, I don't know if you've ever seen it, but sometimes they're just crawling with satellite dishes. Everybody in the apartment has to have their own dish. Well, every signal that comes in from the outside world has to have its own little dish to recognize it. Now, some of these dishes can recognize a couple different signals, but if you're a hormone that can't slither through the membrane and get into the cell, your only other option is to bind to one of these things and send the signal through, as you'll see later on in one of my other videos. Okay? All right, so this is a mitochondria. You may have learned about that in high school. It's the blank house of the cell. There we go. Good job. So you can see the electricity coming off. Now that's not totally a joke, too. There's an electric charge between the inner and outer surface of that drives the power production motors inside there. And there's, of course, little motors on the outside called kinesins, and now that's what I study at Wake Forest. And that carries things along these rails from one place to another. Now, just to give you a comparison in size, this mitochondria is a lot bigger than that bacteria you saw on the first movie. In fact, bacteria are so small that even though we only have a few areas of our body that have bacteria in them, namely our small intestines and our skin, there are more bacterial cells in you than there are human cells. I said there are 100 trillion cells that are human? Well, I kind of lied. More than half of those are bacterial cells. So you're outnumbered, okay? But they're really small, so you don't have to worry. You still have more brain power than they do. This is another picture of the same railway system drawn by the same guy that did that membrane picture I showed earlier. This guy's an amazing artist. I invited him to come to Wake Forest to speak. He spoke to the physics department and to the art department, because he has dual degrees. And so he's created this massive mural. This is just one small inset of it. What you're seeing is the rail system, all these things in red. You can, if you're up on the front table, and later maybe you can come see, there's little motors pulling all these things. And then there's this red structure here that's like a soccer ball around it. So basically, these things operate in the following way. And I'm going to let the movie play here. Hold on a second. Just a little worried nobody in the back can see anything. Okay, but you see how they're forming? They're forming like a soccer ball. Each one of these threefold symmetric building blocks can lock into place, and what they're there for is to pinch off pieces of that membrane that you saw earlier. So the membrane is a nice fatty layer around the cell, and when you pinch off pieces of it, you get little bubbles. Like inside of this one, inside of that cage, there's a bubble. Here's another lumpy bubble. There's another lumpy bubble there. And those operate as cargo holds for the cell. Kind of like semi-trailers that go from to and fro. And believe me, on my way from Winston-Salem down to Anderson, I saw a lot of tractor trailers, okay? And the cell is crawling with tractor trailers as well. In my research, I study the motors that carry the tractor trailers. I can't see the motors because they're so small under even the best microscope. But I can see the tractor trailers, and I can follow them like a sky cam, like a police helicopter, to see how fast they're going, whether any of them are breaking the speed limit, etc. But I can figure out things about how the motors work, and that's my research. Okay, so I think we've got a good picture of what's going on here. We're back now inside the cell following that hormone molecule we saw earlier. What is this giant thing that we're seeing? It's called the nucleus. So it's inside of every human cell except for blood cells, red blood cells. And it's got these little gates that allow things in but not other things. They're called nuclear pores. Not very original, but that's what they're called. And a hormone molecule is small enough to probably just slip right through. It doesn't need any pass to get in, but everything else needs like a little ID card to get inside of the nucleus or to get out. And that's because this is where all your DNA is stored. So it's a very important place. It's like the library that's right behind us. you can't just go in there and take a book out. You have to have a card, you have to have a pass. And some books are so valuable, they probably won't even let you take them out. You can make a photocopy, but you can't take them out. In fact, that's how our nucleus works with DNA. You can't take the DNA out of the nucleus. You can make a copy in RNA and bring that out and use that for whatever you're doing. But you can't use it. Now, this is actually what's going on here. The hormone is a growth hormone. And it is activating a, not very original, but a growth hormone receptor. That's the name of it. It's a growth hormone receptor. When it gets a growth hormone bound to it, when it sticks to a growth hormone in the right spot, then it can find one of its fellow growth hormone receptors and form a little duet. And the duet has enough strength to stay on a piece of DNA. By itself, it doesn't stick, but with another friend, it can stick to the DNA. When it sticks to a certain part of the DNA, it recruits this machinery here. And this machinery is the photocopy machine. It's taking the DNA and making a temporary RNA copy that can go out of the library. Okay? And you'll see that in just a second. I think I've got that next movie queued up. You can see it's all wrapped around the DNA. It's going to wind its way along here and make an RNA copy. Here it goes right here. You can see it spins because, as you know, the DNA is a double helix, which means it's like a spiral staircase. And so when things go down it, they actually have to go around and around and around. And that's okay. Nobody gets dizzy inside the cells, all right. What you see coming out the side of this photocopy machine is the photocopy. It's coming right out the side, and it has a perfect match to what the DNA is, word for word. It copies all the genetic information, and it sends it then outside of the cell for the cell to use. Okay? This is molecular biology 101. I know you guys are learning something here, I hope. Hope it's sticking in your brain somewhere, because this is fascinating stuff. This is stuff that, if you believe in God, God made this, and this is part of His handiwork. So it's going outside of the nuclear war, and this is an old French film that, believe it or not, the guy who founded Pixar and I were at a party together, and when he found out that I was a budding molecular biologist or biophysicist, he said, you gotta get this movie. 1997, he was on a committee to look at movies, and this was 1998 or something. He said, I just saw this movie, it was great. So I paid my hard-earned graduate student dollars to buy a VHS cassette. It was $128. I had to get two of them, because it was split into two different VHS cassettes, the first half and the second half. But I never regret paying that money, because it was really the first molecular animation. People had done Toy Story and VeggieTales, but they hadn't really animated what goes on inside the cell, stuff you can't see with a microscope. So this is the only way I could get a clear picture of what's going on. This is from the same movie, from this French animation. Now we're back inside the nucleus, and that piece of RNA that went outside the nucleus, it was there to tell the cell to make some of these machines. These machines are not photocopy machines. These are printing presses, because you're taking this precious book that nobody lets out of the library and actually printing a new book from that old book. And so now I have two books. Okay, so one book comes in, two books go out. Okay, and it's again an exact copy. This is DNA replication, which is what you need if you're going to allow a cell to divide. By the way, this is just a little second part of it. When you have enough DNA to divide the cell, one of the key components is keeping it all organized, because it's like having all these pages all over the place. So the cell has a very nice way of compacting DNA. First it wraps around these little spools, then it puts them into fibers, and then the fibers get compressed into these loops by these little sausages, cocktail sausages, of course. I'm just kidding. We don't really know what those things look like. And then those loops get further coiled, the coils get coiled again, and believe it or not, after 5 hierarchical levels of coiling, you get this X and Y chromosome that you've probably heard about, you know? So, I don't know if you can see, it kind of goes off the board, but here's one leg of the chromosome, and here's another leg, so this would be like an X-looking chromosome. Fascinating stuff, right? And then what the cell does, if you watch this movie, you'd see it in the next set, but you'd see that these little red discs are where the cell pulls the two chromosomes apart, daughter chromatids they call them, to the different sides of the cell, and then the cell can divide. So that's sort of the movie shows, from beginning to end of the growth hormone coming in and allowing the cell to grow, i.e. to multiply into 2 cells. Okay? So a little yeast leavens the whole lump. Okay, this is exactly how yeast do it. Yeast are single-cell organisms. They grow, they send off a little DNA into a bud, it buds, that thing grows, and it just keeps going like that. Okay, so here's that same machine that was on my cover slide. This is the DNA copying machine. It looks a lot better in this picture because we had more information than the French animators did. Before you just saw one strand coming in, 2 strands going out, it was kind of a lumpy yellow thing. Well, now you can see some of the components. This is not all the components. You can see that there's this first part here in blue that splits a double helix into 2 single helices, right? One of the single helices goes this way and gets copied right away. Okay, so you can see it's double helix here, single strand there, and then it comes out double again. Okay, so now you get from 1 to 2 halves, and then this half becomes a whole. Then this half becomes a whole, but only backwards, because it's going the wrong way. One strand of the DNA goes this way, the other strand goes that way. One strand is the easy strand. The other strand is like a truck that has to always back up. Okay, and that's what you're seeing here, is that it's kind of always being carried from here to here so that it can go backwards, okay, and run itself backwards until it hits the previous part. See, there's the single strand there, and it's turning into a double strand there. It's a little confusing, but the point is, it's amazing. All these little pieces going back and forth inside every one of your cells that is copying its DNA, which in your stomach, you're constantly losing cells on your intestines, and so you're constantly getting new cells. In your skin, same thing. Constantly getting new cells. If you stop making new cells, you're going to die. So hopefully this is happening to you right now. Okay? Now, this movie actually comes from the movie Expelled. So you may recognize parts of this. I was privileged to help the animators do all the science so they would know. Now, what you just saw was the radio dish, the satellite dish. I forgot to mention. But there was a signal that came in and it went across the satellite dish and it went through. Okay, so I promised you I'd show you that. Now we're diving deeper inside the cell. Here's the nucleus down here. Here's the railway system coming all out, and you can see there's some of these bubbles that are carrying things along. The motors are carrying them, and the bubbles are like the trailer part of the tractor trailer. Here's where all the railway system starts, back there, and this is the road crew tearing up a road that you don't need. Okay, they actually have these things inside the cell. They walk along the road, and they tear it up behind them. It's very convenient. Here's the little green signal that we were following from the outside of the cell that got transferred through the radio dish. Oops, now it's getting transferred across the surface of that lipid. So it does stuff like that. And now we're going to dive into the nuclear pore again. Okay, let's see what happens here. I can scroll forward. There we go. Whoops, I didn't press it too many times. There we go. Oh, it says media unavailable. Oh, that's painful because that was the best part. Oh man. No, seriously, not just saying that. I might have to find that at the end during our Q&A so you can really see that. But I probably am losing you guys anyways, so it's okay. We'll skip to the final. This is probably the nicest one, and I lied when I said I didn't need any sound. There is one point at which sound might be nice because it's got such pretty music. So if I plug this into my sound thing, okay, let's see if this one works now. Oh, no? Let's see here. There we go. Play. So you can tell me the media is unavailable. Maybe my whole hard drive just malfunctioned. Come on. Well, the good thing is that both of these are very recent animations, and you can find them on the internet. Oh, here it goes. Wonderful. Okay, can you turn up the volume just a little bit? Oops. Okay, here's the music, guys. All right, here's a rolling white blood cell. The reason it rolls is because it forms a molecular Velcro with the surface of the inside of a blood vessel. Part of the molecular Velcro is made up of these strands on the surface of the cell. There we go. A little louder still. Okay, this is looking up at the underside of the membrane. And what you see is there's a crisscrossing pattern of protein strands. Okay, and now we're diving down deeper inside the cell. This is like a little elevator shaft. We're going down, and you can see that the cell is held together by these coils. These coils are like cables that self-assemble from little bricks. Okay? And if you need your cables cut, well, there's a machine in the cell that can cut the cables. Here are the same molecular roads. In the earlier show, you saw them being peeled back by motor proteins, and that's what happens. This is the part that I studied. Isn't that cool? It literally walks 1 foot in front of the other as it carries these cargoes from one place to another. And it does that by burning up the energy that's produced in the powerhouse of the cell, in the mitochondria. There's where all the roads start. All roads lead to Rome. That's called the centrosome. It rhymes with Rome. And then here is the RNA, that temporary copy that we made from the DNA. You know, it may not be your fault. I'm just going to turn on. Oh, now the music's good. I threatened it. Okay, so these are different proteins that were made. Maybe it isn't. I'll mute it. You don't have to have the pretty music. Okay, this is where the RNA gets turned into something useful. So the RNA is just a blueprint, and when it grabs onto that thing called the ribosome, it actually turns into something useful. A protein, or a motor like this, or some bricks to form something. If you guys study biology carefully, you not only know that the ribosomes copy this, but that was a Golgi body that we just saw, okay? And of course now you know Golgi body, mitochondria, ribosomes. You're ready to take a 10th grade biology test, so you guys are good. These guys are called interleukins, definitely not 10th grade biology material, but they get together on these little rafts of slightly different kinds of lipids that all like to stick together. And there you see the white blood cell is rolling where all the red blood cells just flow through naturally. White blood cells are patrolling the cell, looking for infection. Look at what it does. When it finds an infection, it slips between the cracks of 2 cells, and then it fights off the infection behind them. So if you get a blood infection or an infection behind your blood vessels, these things are constantly rolling around on their molecular Velcro, sniffing out any problems. And when they find one, they stop, drop, and slither. And they go right between 2 cells and fight off the infection. So I think that is a good amount of movies. Let's applaud the creator of all this stuff. Not these guys. These guys were the ones who put the movies together, but definitely God is responsible. So now I'm moving on to the next part of my talk, and this will be much shorter, so don't worry, that was the longest part of my talk. These are wrong ways to organize views and to frame this debate. But a lot of people still do this, so let's look at what they're doing. They're saying that there are basically 2 ways you can go. You can have more Bible, or you can have more science. Okay? The more Bible you have, the more you become a flat earther. The more science you have, the more you become like Richard Dawkins, or Brian Cox, or any of these, Carl Sagan, all these people, Jacques Cousteau, who really love science and are broadcasting it to the entire world and telling them how great it is, but also how it's just a material world we live in. The cosmos, as Carl Sagan said, is all there ever was, all there ever is, and all there ever will be. Okay, that's the opening line of the show that I sat with my parents and watched back in 1980 on PBS. And that's clearly a very materialistic way, naturalistic way of looking at the universe. But the idea is that, well, if I want more science, I gotta at least start going that direction, especially if I don't want to be a flat earther. Okay? And so you start to organize all these different views, all the debate, around these 2 axes. Okay? And it just forms just sort of a line. Okay? Flat Earth is all Bible, no science, and materialist evolutionist is all science, no Bible. And we might choose to be an intelligent design person because we think it's like a happy medium between Bible and science. And then we're like, done. Okay, that's what I like. Or maybe I like a little more science, so I want to be an evolutionary creationist. Maybe I want a little more Bible, so I want to be an old earth creationist or a young earth creationist. These are not helpful ways of framing the debate. Because basically it's saying it's either science or the Bible. And even if you're here in the middle, you're basically straddling these two polar opposites. And they're not together. Plus, it doesn't really get at what the views are. It puts everybody on one line, and it assigns you basically a place in line. Okay? You're either there or there. And you just, basically, it's like a number line. You can either have a 1, a 2, a 3, a 4, a 5, or a 0, or not -1, and that's all the information you have about your view. So that's not a very helpful way to do this. A better way to do this is a way that my friend at Liberty University, Marcus Ross, did with what is called a cladogram. People use this in biology all the time, especially fossil experts like he is a paleontologist, Marcus Ross. And so he finds what things they have in common, like common descent. What things do they share? What features do they share? If these were animals, these would be things like, these two are just different kind of lizards, okay? And this is maybe a snake, okay? This is like turtles and crocodiles, okay? So they're all reptiles, but down here, the reptiles diverge from fishes, okay? So this is where all the fishes come off, this is where all the reptiles or amphibians or whatnot, okay? So you can imagine this, you've maybe seen this in your biology textbooks. Okay, now what are the things that distinguish between all these guys? There are, according to Marcus, all of these different views, okay? And you can read these, and we can take a little time to read what things might distinguish between different ways of looking at origins. First, is real design something that really exists in the biotic and or abiotic universe? Meaning, does real design exist inside of the cell? That's the biotic universe. Does real design exist in the fine-tuning of the constants of the universe? That's abiotic design. Detectability. Can you really detect design? By the way, B is the one that I think is most important, as I'll share a little bit. You might believe that the universe is designed because you're a Christian, but you're a part of a group that says, but I think God hid that from us, and there's no possible way to detect that real design. Okay? There's also the issue of agency. Is the agency something that has corporal nature or non-corporal nature, intrinsic or transcendent? Is it a deistic person who wound up the universe, or is it a theistic person that is involved in the universe? And then, would you say that biological complexity is something that came on the scene once in the past and then has been continuously evolving? Or is it discontinuous? By the way, if you're interested in this, this is available at Liberty University. You can download the whole PDF. It's also a chapter in a book that I edited with my friend Bill Dembski called Darwin's Nemesis. And this was a tribute to Philip Johnson, like a Festschrift, you may have heard of that word, in honor, I think, of his 65th birthday. And so you can find all these things, you don't have to write them down. And then lastly, what is the age of our Earth? Is it universe, is it 4.5 billion, or is it more like 10,000, the universe that we see? Okay, so these are some of the things, and then if you organize them, what you see is you do get a ranking, but there's a lot more information in the ranking. It tells you who are kind of like kissing cousins of each other, and who are way far apart, and why are they way far apart? Okay, if they don't say anything about something, there's just an X. If they say the answer is no, like in binary, that means 0. If they say yes, like in binary, that's a 1. So this is the table that you would create, and this is again in that paper you can download from Liberty University. But you can see that a young earth creationist believes the answer is yes to all these things, or the second choice. So even with part G, they believe that the universe is only about 10,000 years old, where an old earth creationist has all the same views, but that last question they would say, no, it's more like 4.5 billion years. Then a strong theistic evolutionist versus a deistic evolutionist versus a weak. All these things are very interesting positions, and it's a much more fun, informative way to carry on the debate, I think. And we can have much more friendly talks, much more light and less heat when we organize our thoughts this way. Okay. Now I'm getting to the part where I get biblical here, Luke 18, 9 through 13. I'll read this one too. Jesus, he told another parable. This comes from the New Translation, The Voice. If anybody has any familiarity with that, I'd love to talk to you afterwards. I'm curious about this. This one addressed to people who were confident in their self-righteousness and looked down on other people with disgust. Jesus. Imagine two men walking up a road, going to the temple to pray. One of them is a Pharisee, and the other is a despised tax collector. Once inside the temple, the Pharisee stands up and prays this prayer in honor of himself. God, how I thank you that I'm not on the same level as other people. Crooks, cheaters, the sexually immoral, fill in the blank, which Origen's view you don't agree with. Like this tax collector over here. Just look at me, I fast, not once, but twice a week, and faithfully pay my tithes on every penny of my income. Over in the corner, the tax collector begins to pray, but he won't even lift his eyes to heaven. He pounds on his chest in sorrow and says, God, be merciful to me, a sinner. And I share this because we all love this story. And on my way to a talk at Wheaton College, where I used to be a professor, I was speaking on origin issues, and I just thought, I went to a liberal church, a church that I would probably not want to be a member of, but my uncle sang in the choir. He's not a Christian, but they paid him to sing, and he's got a good voice. And I sat and heard the guy's sermon, and it was on this. And I thought, look, I'm looking down on this so-called liberal church because of whatever views I don't agree with or whatever. And I thought, I'm just like the Pharisee. And so many other people in the origins issue, me too, look down on people for having the wrong view. And I thought this really captures so many of the issues here, and I thought we'd share that as we move forward into the Q&A session, let's keep this in mind. As we move out of this conference, back to our places of work and study, keep this in mind. Don't hold on to your view so tightly, because you might be actually the Pharisee. Whereas a person who's more humble to know, I'm a sinner, I'm also sinful in my understanding. I can't understand the logic the way God probably wants me to. So even if I think I know everything, intelligent design is the wave of the future that's going to knock down all the other arguments, well, maybe I'm not right about that. And you just have to have this kind of attitude. I think that I'll stop there. There's a lot of people to acknowledge, and I'm just verbally acknowledging Bill Dembski, who has mentored me and also suggested me as a person to replace him when he had some serious family health issues, and my colleagues at Wake Forest who put up with me, even though I believe all this crazy stuff, and they gave me tenure, which is amazing, and just a lot of people through the years who really just poured their lives into me and taught me what I was sharing with you tonight, teachers in high school, college, all the way up. And so I really appreciate all of them, and I especially want to appreciate my wife, who is right now back at the hotel watching the 5 kids so that I can be here with you tonight. But don't let that stop you asking questions, because she wants you to ask as many questions as you want, and she's happy when I can help move things forward in a positive and friendly way. So I'm going to turn the mic over to you, or if you can just stand up and say something loudly, I'll repeat the question in case people haven't heard. So go ahead and stand up. Thank you for your time.
I'd like to commend you for your presentation of intelligent design for dummies. Because, see, this is a problem, the scholars communicating with ordinary people. And intelligent design, whether we agree with it or not, it needs to be communicated on a popular level. I just gave a paper up at the Eastern ETS on textual criticism for dummies. Now, I'm not a scholar in that area, but I felt that this needs to be boiled down for the average pastor even to understand, because there's so much exciting information about textual criticism today, the papyri and so forth. But you have done a marvelous job in communicating, and I commend you if you could stir up the other intelligent design people to communicate to ordinary people like us.
Yes, well, you're absolutely right. We all need something for dummies, because we're the tax collectors. We don't understand things. And on a personal note, after I spoke with Ken Turner, I had to get on Wikipedia and find out what is the difference between hermeneutics and exegesis. I mean, come on, like I don't know this stuff. You guys all do. So thankfully, Wikipedia steered me in the right direction. I hope. So go ahead and ask your next question. Yes, go ahead. And say your name too, since you guys are getting to know each other. Okay.
I started a creation study group here, meets once a month in the library.
Wonderful.
I'm a young earth creationist. I make morphologies. I get that from scriptures. That's science, interpret scripture. Can you comment?
Oh, you're being humble about it too, right? You're definitely being humble. I can tell.
Well, Jude says we're to earnestly contend for the faith. We're in
That's
the
true.
form of God, take the sword of the Spirit. So there is a war going on. The battle is for the beginnings. The battle is for the authority of Scripture. I think that's what's at stake. So all that stuff, we have to keep that in mind.
Mm-hmm.
There's some that say that the satanic attack today is on Genesis chapter 3, and that the pagan religion of today is the millions of years. And that's something to think about. But my question for you, can you comment on the genetic entropy in the human genome?
Oh, I'm familiar with that. So John Sanford is a friend.
Thanks very much. This
Yes.
is fantastic.
He really has done a great job. He and I were both invited to a couple of conferences in Pittsburgh by our friend David Snoke, who's a tenured professor in another physics department at the University of Pittsburgh. And really a great guy. So he invited me, Bill Dembski, and John Sanford to talk about these issues. And I was impressed. I mean, very impressed. And if I've done my job tonight, you don't know where I stand on old Earth versus young Earth. Okay? I didn't want you to come away thinking, oh, he's a young Earther or he's an old Earther. I would love it if every one of you who holds a view strongly, as you do, just pretended I hold your view. Just pretend for tonight that I hold your view, because I think it'll allow us to have a much more fruitful conversation. Pretend that I share all of your views, and we're just having a conversation between friends, where we can also play devil's advocate for our own view and say, well, some things are not worked out. The guy who does this really well is Marcus Ross at Liberty University. Credits to him. He says very openly, I'm a young earther, unashamedly, but the evidence from science right now does not point to a young earther. The evidence points the other direction. However, he believes that someday it'll change. And, he's acknowledging that he's sort of waiting. That's more than a lot of people do. But other people on the totally other side are equally humble, like Marcus. For example, I invited a guy named Norm Pace to a small class that I was teaching at Berkeley. Berkeley is so liberal that they have this thing called democratic education at Cal Berkeley, DeCal. And anyone can teach a class for credit. Can you believe that? So there are classes on the sexuality of Madonna videos, and pedophiles in The Wizard of Oz, all this nasty stuff, and you're like, what? But hey, we can use that too. So we said, okay, we'll teach a class on intelligent design and give people credit for it. It wasn't exactly intelligent design; it was exploring these origins issues, like you do once a month here in the library. And students took it and got credit for it, got graded for it. So it was awesome. And in one of those classes, Norman Pace came in. He's an evolutionist to the top of his head, and an atheist to the top of his head. And this little, freshman girl said, but Dr. Pace, how do you know that all of this stuff that you're showing us came about by chance? And he just said, honestly, I don't know, but I have faith that someday we'll figure out how it will happen. Okay, so he's waiting on the evidence for origin of life. Just like my friend Marcus Ross is waiting on the evidence for a young Earth. It's so helpful to acknowledge that you don't have the evidence in your back pocket. Because then, it's like you're not bluffing anybody. And people respect you. I respect Marcus so much because he said that. Because now I can sort of see, okay, well, what evidence do you see pointing directly against your field? And I actually called him up before this talk because I wanted to chat with him before I gave this talk. And we had a long chat about things that pointed against and things that are now pointing towards. a younger physician. So it was fascinating, and he just does such a nice job. He's a model of the kind of tax collector prayer that we need to have in this arena. Somebody had their hand up, and I just was going on and on. Did you want to say something?
Yeah, that'd be great.
James Lemaster. Okay, James Lemaster. From which place?
From Southern Baptist Seminary in Louisville.
Okay, Southern Baptist.
Yeah. Two questions, but I better just ask one. This is probably easy. From your position now as a scientist, do you think that intelligent design is testable?
I think it's absolutely testable. This is great. I'm glad you asked that, James. James, I just paid him to say that because there was one thing I really wanted to talk about. There's this brand new paper that came out. And what does it say? Are there any sci-fi buffs here that know about, I know there's lots of sci-fi buffs, we all love sci-fi. But do you guys know about the WOW signal that was picked up by SETI, Search for Extraterrestrial Intelligence, in 1977? You do? Tell us a little bit about this. Stand up and tell us if you know something, because I don't know anything about it. So stand up and say, what is the WOW signal?
That's really all I know about.
Okay, there was a WOW signal and it was 1977, right? Okay, does anybody else know more about it?
Yeah, SETI got some signal hit the SETI radar array, and they said, wow, they were convinced that it was an intelligible and intelligent communicator, attempt at communication.
Okay, anybody else know anything else about it? All I know is that, just like what you said, and that never happened again. And it basically got thrown out as maybe just noise or something. But it was really, at the time, very convincing, the pattern or whatever you look for. If you've seen the movie Contact with Jodie Foster, it's that kind of thing that they were trying to look for and they thought they had found it. This guy wrote a paper about how the genetic code is a WOW signal. And he goes through, and I read the whole paper, beginning to end. It's very dense. Not recommended reading for you, James, who's an 11th grader, right? Or an 11th grade. But it's pretty intense. And he argues strongly that what you see in the genetic code, which if you caught it in the ribosome, you go from RNA to useful proteins. And there's a coding system. 3 letters of RNA gives you 1 letter of protein. Okay? And you may know about this. But anyways, so there's basically, since there are 4 letters of the DNA and RNA alphabet, and there are these 3 positions, it's 4 to the 3rd power, which is 64. Okay, if you do the math. 4 times 4 times 4, 64. And there's 64 different ways you could specify the 21 letters of the protein alphabet. And this guy strongly argues that the exact choice of these 64 ways going into 20 different amino acids and the stop codon are done in such a way for us to pick up a WOW signal from an intelligent source. This guy wrote the paper and published it in one of the leading journals of astronomy and astrobiology, Icarus. And he is not a Christian at all. He's an atheist, the pair of authors that published this. And they're not trying to say that it's an intelligent designer in the sense that you all would, God or a supreme being. He's just saying it's an alien. And is it so far-fetched? Absolutely not. Before he even did this study, back in 1977 or even earlier, people said, well, wouldn't it be smart to send not radio waves, but life forms, bacterial life forms, to other planets? But not just any bacteria that have messages encoded in their DNA. You're like, how can you encode a message? Guys, it's already been done. Have you heard of the Human Genome Project? Obviously. Have you heard of Craig Venter? Obviously. Well, some of you have. He was one of the 2 guys that was doing the Human Genome Project. There was the government guy, who's also probably famous, Francis Collins, who's now the leader of the NIH and who wrote the book The Language of God, and who's a Christian. And this other guy, Craig Venter. Craig has already encoded his name. Craig Venter is cool. All kinds of graffiti in genomes that are now being grown up in bacterial cells. Okay, and he's on the cusp of creating an entirely synthetic genome. Entirely synthetic. So this is not far-fetched. This is happening today. So these people back in the 70s who said, yeah, it would be smart to encode a signal, and not just in the DNA, but in the genetic code itself. Because why? DNA gets mutated all the time. The signal gets washed out. But the genetic code stays constant. If you believe in evolution, it's constant from the very first genetic code on, because we all share the same genetic code as with every other organism on the planet. Minor exceptions, and those exceptions, this author said, just prove the rule. And also, in one case, he said might even have even been an alternate signal that came in at the same time as the earlier signal. Anyway, the point is if this guy, who's not a Christian, can publish a paper in a leading journal that says there is a sign of intelligence from somewhere else in biology, that means intelligent design is scientific and can be tested. This paper, with the claims it makes, the probability levels and thresholds it sets for how probable it is that this is merely by chance, and it's extremely low, he says, can be tested by other scientists. So, in answer to the question, is intelligent design? Yes, it's testable. Is it being allowed to be tested freely and openly with government funding? Of course not. But neither is this guy who's doing his work in Bulgaria or something like that. He's a Russian scientist. You know, he doesn't get a lot of funding for what he does. I went to one of these Origin of Life talks. That was a small part of a larger conference on protein. Okay? The conference was huge. It was held in this wonderful, downtown convention center in Boston, with a big banquet, tons and tons of people there. When did they hold the Origin of Life presentations, the talks and posters on the Origin of Life? The last day of the conference at 9 p.m. at night, in a room like a third of this size, maybe a fourth of this size, and there was 2 tables of people sitting in rows. They're not very well funded either. Okay, so it's not like it should be that surprising that intelligent design would be a lot of funding. Okay, it shouldn't be that surprising because it's kind of a little bit maybe not so clinically relevant. It doesn't really change your diagnosis for when you have Alzheimer's or diabetes or something like that. So it's not going to get NIH funding. So I mean, but it could be better. I've been maybe the victim of people not liking intelligent design and not wanting me to be around them. But that happens for a variety of reasons anyway. So okay, lots of questions here. I'll take your question, then in the back, and then here.
Dave Breyer from Mercer College. I think my question falls under the detectability theme. And this is actually, I wanted to ask Bill Dembski about this. Here's the way he defined intelligent design at the beginning of his talk. He said, intelligent design is the study of patterns in nature that are best explained as the products of intelligence.
Right.
So what I was thinking is if, as we probably all think is the case, most of the patterns in nature are best explained as the products of intelligence, then I think this implies that pretty much, I suppose the vast majority of scientists are doing intelligent design. Because they are studying patterns in nature that are best explained.
Well, they're not acknowledging the final clause that are best explained by intelligence. The word best, if they can replace that with poorly, or never in a million years, or not over my dead body, then they would be doing exactly what Bill Dembski said. But obviously they don't accept best. They do not accept best.
I thought his definition didn't require them, just the study of patterns in nature that are, I took it to be in fact best explained.
Okay, well, if you take it that way, then it explains why most intelligent design theorists are parasites, pariahs, because they feed off of other people's research. Okay, if you look at B.E.'s latest book, it's not very recent, The Edge of Evolution, which, by the way, is my all-time favorite book on this topic. Why? Because he goes through and uses real data from malaria, AIDS, and a guy named Lenski at Michigan State. and his bacterial experiments. 3 different sets of data. And he goes through and describes how much evolution can really do. Where is the edge of evolution? Where does it stop being able to do anything? And he thought, before he wrote the book, that evolution could go all the way up to the origin of life. That evolution had the power, basically, once you get the origin of life done, evolution can cover you all the way up. Paint it all the way up to that line, but not above that. And he found out through real data, you can only paint it up to the level of species, genus, family. Okay? And that was kind of a shock to him. I mean, he's a Catholic, he doesn't really care where the line goes. But the data said that. Okay? But he was feeding off of other people's data. People who did not accept the best word, but who were, as you say, studying things that all of us think are designed. In not only, he didn't restrict it to nature biotic, but abiotic. So things like, is fine-tuning something that evolution, or at least natural processes, can do? So it's fascinating. Now, I said I'd go to the back, and then over here. Did I miss somebody? Okay, go ahead. What's your name?
My name is Robert Yost. I'm at New Life Theological Seminary in Charlotte.
Okay.
And I guess my question is, how is just an average person, how do I not feel overwhelmed? Now, let me confess to you that when I was an undergraduate at the University of Maryland over 40 years ago, I was required to take 2 science classes. I made a D in geology. These are secrets that cannot be disclosed. And it was spring, and I spent a lot of time playing my guitar outside rather than going to lectures. And I failed biology the first time, and I didn't exactly set the world on fire the second time. I did make C. So that
Good for you. C is good. I teach classes in physics for just your kind of student. They call it football physics.
So that was my scientific career. So now, as a biblical scholar who grew up in a fundamentalist church, and the attitude was, well, the Bible says that I believe it, that settles it. And so I tend to want to believe in a young earth, and I believe in a literal hermeneutic for Genesis 1 through 11, as I do through the entire book of Genesis. How do I not feel like a total idiot
When you're faced with these
I'm
issues.
dealing with maybe a biologist who is unsaved,
Right.
and I'm sure that probably what I'm saying resonates with some people here. Maybe you feel the same way I do.
Well,
I feel overwhelmed by
Here's what I would advise. Okay. How many of you ever heard of My Utmost for His Highest by Oswald Chambers?
We do it every year.
Okay, good. Well, then you should be able to take this advice, even though you might not like it at first, because it comes from Oswald Chambers himself. His big mantra to his students and people who studied with him was, do the hard work and get knowledge, get understanding, get learning. Okay? Don't give me any of this excuses. Learn it. And he practiced what he preached. If he was interested in a brand new topic he had no background in, that he may have gotten a D in or a C in earlier, he's going to try it again. Okay? No excuses. He would really recommend just bearing down and learning the stuff. And if James in 11th grade can read these books, you should be able to read these books too. Okay? You don't get to withdraw questions in this case. It's all on video too, okay? So you better do it now, all right? I'm going to come check on you down in Charlotte, really an hour away. I'm going to check on you, okay? You better be reading some of these books because you have no excuse. And you will impress the biology professor who comes to you with some questions that you've actually tried. You've actually tried. And, no excuses because God's given you a brain. It's not like I was born with a biological brain, you were born with a theological brain. That's not true. We're born with brains. If you're smart in theology, you could have been smart in biology if it hadn't been for that guitar you were playing. You could have been. Now's the time to redeem it. And I don't mean you should should go out and get a PhD, although I could happen, right? But you can at least read the books. It's not that hard. And I was explaining it. You said I did a job for dummies.
Yeah.
There's books out there for dummies written by great materialist atheists. I think Dawkins is one of the best writers on understanding science and understanding, at least how it actually works, the facts of the science. Not so much the interpretation, but the facts. You're in the back, but actually I was going to take somebody in the front first, but I got your question there. So were you going to ask a question?
Okay, sure, yeah. The intelligent design. Wait, Drew Bassett, Liberty University.
Okay, Drew and I had some good conversations over dinner.
All right, so this is largely a scientific hypothesis, right? Intelligent design, right?
Largely a scientific hypothesis.
So we as theologians and philosophers and biblical studies people and philologists of ancient languages, what does this have to do with us?
Okay, well that's a great question, Drew. Thank you for asking. And just to repeat it again, what does a primarily scientific theory, because you stated it very nicely. What was your name again? Dave Wright. Dave stated it very nicely that it's just about studying things in nature, which is a very scientific thing, and hypothesizing that they are best explained by design. Okay, making that hypothesis, not being afraid to say best. So what would that mean to people? Well, obviously, you guys are studying the Bible, okay, all the people you mentioned. And in the Bible, not just in the first 3 chapters, but throughout the whole Bible, it's talking about God being the creator. It's premised, every verse is premised on that, as a famous preacher in the style of Martin Lloyd-Jones, but I can't remember his first name now, or his name, Martin somebody, but he said, we have an inescapable obligation to render absolute obedience to our Creator. Okay? Anybody know who said that in a sermon? Martin somebody. No, not Martin Lloyd-Jones. It was some on video cassette, so it's not him. Anyway, inescapable, think about it. Inescapable obligation to render total obedience to our Creator. Why? Because He's our Creator. He made us. We are the potter. He's the potter. We are the clay. We have absolutely no say in it. Every theological principle comes back to that. So if that's not true, it all unravels. So you have a stake in intelligent design of some stripe being true. Because if there's no intelligent design, there's no intelligent designer, there's no creator. We do not have an inescapable obligation to render jack to anybody. We are our own island. We are our own people. We can do whatever we want. We do not have to abide by anything the Bible says. Nothing the Bible says means anything to me. Because I'm my own boss. Maybe that's good for you. Doesn't work for me. I am not beholden to anybody because I'm not created from them. I am from slime. Okay? And it happened by accident. Now, of course, I'm setting a straw man argument for people, but essentially it comes down to that. So there's a huge stake in it, which is why I'm telling you to get boned up on this and read the textbooks that you threw away 40 years ago. Okay, pick them back up. They're probably still pretty helpful, and then move from there. Okay? Can you do that? Promise me, a year from now when I come to Charlotte, you'll be...
But think about it.
You didn't ask the question in a way that you wanted me to say that. You wanted me to say, that's okay. You guys don't really need to hear this. Why do you think I spent most of my talk trying to teach you guys something? Because I think it's important. I read one person, actually, I think it was the founder of a lot of the creationist stuff, scientific creationism, Henry Morris, did a commentary on the book of Job, did a commentary on the wisdom of Solomon. He did your job. You should do his job. He was a PhD in a science field. I think it's hydraulic engineering, okay? But he did your job, so you can do his job. I do your job. I read the Bible every day. I know the Bible pretty well. You should do my job, okay? And I'm not trying to say I'm better than you. I'm just trying to, get up to your level because I have a brain too. And he wrote this commentary on Job, and basically he said that the answer from the whirlwind was really about this. It was about us not appreciating science enough, not appreciating creation, and therefore the Creator enough. And why he spent all that time, God spent all that time giving Job a lesson on biology, geology, and atmospheric science. because that was really what Job needed to hear.
Circle of the earth.
Yeah, I mean, that's what he needed to hear at that moment when he was at the bottom of the ash heap, scraping himself with a piece of pottery. He needed to hear that God was the creator, and he had an inescapable obligation to render total obedience to his creator, no matter what happened, no matter what the creator did. He did not get out of that obligation just because he got dealt a bad hand. And that's what he needed to be reminded about. And so we need to be reminded about that on a daily basis. And it's up to all of us, whether we are scientists at heart, a scientist by training, a scientist as a second career down the road, 40 years later. We all have to remind people of the Creator and how we have to render absolute obedience. There's nothing you can do. If you're the pot, you render absolute obedience to the pot. So, there was a question in the back. You can rescue us from this awkward silence.
Don Williams, Dakota Falls College. In the Origin of Species, Darwin rather prophetically wrote that anyone who is more impressed by anomalous data than by explanatory power will reject this theory. Anyone who is more impressed by anomalous data than by explanatory power will reject this theory. That's exactly how it's played out. One of the gaps between creationist science of any kind and standard science that I just can't understand why I haven't heard more about is when you talk to real practicing scientists, they say, look, evolution, the theory of evolution allows us to predict, to make predictions. When you get a virus that mutates and becomes immune to a drug, it's exactly what the theory led us to expect. But you guys, from the creationist side, all you do is find things that we can't explain. All you do is try to poke holes in our theory, but you've offered no alternative paradigm that we can use to make predictions. Consequently, we're not interested in what you have to say. Now, it seems to me that intelligent design is the first offering from our camp that has the potential to bridge this gap. And my question is, does it give us a paradigm we can use to make practical predictions that could have explanatory power that will impress these guys on their own ground? Because we're really good at poking holes in their theory, but until we provide an alternative way of predicting results that actually works in anything other than just arguing about origins, we're not really participating in the scientific conversation that they're trying to have. It's one of the reasons why things like ID keep getting granted as non-science unfairly, because in fact you do have testable results and rigorous logic. But is the ID movement going to address the issue on this level? And
That's a great question. I'm going to stop you there before people lose the train of your thoughts, because they were very good. First of all, what's your name again?
Don Williams.
Don Williams from, where were you?
Dakota Falls.
Okay. Don Williams brought up some really good points that I'm going to follow up on. And who was it who was saying that people who pay more attention to the anomalous things rather than the main data should,
Charles Darwin.
Okay.
In the Origin.
In the Origin of Species. Okay, I read it. I don't remember that part, but I'm sure he did. He had a brilliant way in that book of using rhetoric to try, not in a bad way, to convince his audience that he was right and other people were wrong. That's what you got to do when you write a book. And so, he made a lot of the fact that, people who look for the little, spurious detail over here in the corner are really not to be trusted. The people who stay with the main flow of all the data, that's who should be trusted. And by the way, that's me, that's Darwin, that's me, and that's Darwinism, and so you should stick with that. And it was a powerful rhetoric. Who wants to be the guy chasing off the little butterfly over here when the main flow of data is over here? I would argue that's not true about him, even at that time, even later, even now. That's a whole other issue. But your question, Don, was, are the people in the intelligent design community trying to counterbalance this, this branding of creationism as the people chasing the little butterfly over here and ignoring the main data? Okay? And you would say it has really happened, that the creationists have been chasing little minor variations, minor problems. And I'd say maybe that's true. Yeah, there's some truth to that. There's some truth to that.
How minor they are.
Yeah, you know. Well, but they've been chasing things like why radiocarbon dating or radio dating or carbon-14 dating is not right. Or, you know, maybe they've been chasing certain things. But, you know, let's just say this. Let's rephrase your question in a way that we all can agree. Okay? Is intelligent design going to be able to get away from the moniker, the slanderous, you know, tar and feathering moniker, creationism in a cheap suit, cheap tuxedo? Some of you guys have heard this. Creationism in a cheap tuxedo.
Will it make predictions?
Will it get beyond that moniker by doing real science? By being a real player at the table. Not just whining and complaining, oh, we got branded as creationism in the cheap tuxedo, isn't that too bad? And this brings me down to a point I told my wife I was going to make. I told her I promised I was going to make it, and if you hadn't asked that question, I might have forgotten to make it. Philip Johnson says the following. It's very important to hear this. You can't be marginalized unless you let yourself be marginalized. Okay, so gentleman over here, what was your name that started from Anderson? Stephen. You can't be marginalized unless you let yourself be marginalized. Unless you don't do what Don is saying in the back. Do the science. Do the real science. Make a prediction that will come true. And this also gives me an opportunity to talk about the two faces of intelligent design, something that Bill and I agree needs to be more widely understood. The two faces of intelligent design. On one side, you go to nature. This is one face. And you see if things are irreducibly complex. Okay? You see if there's complex specified information. You look around. You look around for that watch on the heath. You pick it up. And you say, this is obviously the product of a designer, because no way a watch could just be formed by the weathering of a stone because of all the intricate mechanisms. Okay, the watchmaker. And that's William Paley. Okay, so that's one face, the William Paley face, the looking for design and complex specificity. Okay, the other face, the face that we haven't shown very much, which maybe gets to your point, Don, is where you go into science saying, I assume there's a designer. Rather than going to science, going to nature and saying, what do I see? Can I deduce that or induce that there's a designer for all this stuff because it's so complex? No, you go into science saying, I'm going to postulate, I might be wrong, but I'm going to hypothesize that there's a designer. So, if I find something like junk DNA, that everybody else says is junk, I'm going to hypothesize that it's not junk, that it is designed. Therefore, it has a purpose. Because that's the other face of intelligent design. Actually, that's a much better face in some ways. Why? Because if you made a bold prediction 10 years ago, 20 years ago, and Bill Dembski did, that junk DNA was not junk, you would have been the only person saying that. Everybody else was saying, no, it's a relic of our evolutionary past. Junk just sticking around. What do they say today? Totally turned tables 3 years ago. Totally turned the tables. Now they say 90% of it is not junk. And maybe even less. I mean, maybe even more if it's not junk. Maybe less junk. Okay, so these are the two faces of intelligent design, and I'd say that second face, does that fit the bill of what you're looking for? That's getting there. That's getting there. And Don, you're right. You're right to hold me and anybody in the intelligent design community to a high standard, just like Oswald Chambers holds all of us to the high standard. Okay? We're not immune to this too. And I think we need to do a lot of work and not, feel bad and whine and complain that we were labeled, creationism and tuxedo, chief tuxedo. Don't whine about that. Just do the science. Don't let yourself be marginalized. You will only be marginalized when you let yourself be marginalized. When you don't play by other people's rules and do the hard work. Does that make sense? I'm getting kind of impassioned. You don't think you can be. My wife said the same thing. Well, if there's a bunch of mean kids on the playground, they can marginalize you anyways. I said, yeah, but truth. And Dembski said this: truth will stand. And when Phil Johnson asked me one day, we were driving home from Berkeley. He picked me up on campus, and we drove back to his house where I lived in the basement. He said, "So Jed, what do you think it's going to take for intelligent design to carry the day, given that we have not a lot of money? We don't have the popular press on our side. We don't have the universities on our side. People don't really think we're great." And I had just read the book Endurance about Shackleton. Thank you, Shackleton. And I said, endurance. Endurance, just stick it out. Okay? And that's what you got to do with the kids on the playground. Eventually, if people realize you're not so bad and those bullies are kind of dumb, then you can't be marginalized forever. And there's a big world out there with 7 billion people. There's a lot of people in China that couldn't care less about Darwin. A lot of people in Russia that were crammed Darwin down their throats during the communist days. There are a lot of people out there that are open to the idea. In France, they hate Darwin. They love Lamarck because he's not. Darwin was English. They can't love Englishmen. There's open doors. That little group of people in the Origin of Life community, they were happy to have one more person at their meeting, their little tiny meeting. They invited me out for beers afterwards, because it was just nice to have somebody listening to them and paying attention. So there's plenty of open doors. You can't be marginalized unless you let yourself be marginalized. And you gotta work hard, like Oswald Chambers says. Does that make sense? Should we end it on that? I'm happy to stick around up here afterwards, but I'm starting to get a little preachy. And my wife would probably want me to cut it off now before I say something dumb. Yeah, that's right. Come on up here. I always probably wanted to be a preacher, but I got stuck to be a scientist, so maybe we should switch roles sometime. But thank you for your time. I really appreciate it, and I'll be up here answering questions.